Alternative to practical. This paper contains 5 questions. One of them is about how to plot a graph. In this question, you need first to consider the raw data. Raw data are the data recorded in the table of results, and you need to consider, number one, you should have a proper headings for the table, and the heading should contain a quantity and a unit, like length in centimeters or length in meters. And in this case, you need to consider the device that you used to measure the length in the question, time in seconds or milliseconds, volume in cubic centimeter, temperature in degrees Celsius. Sometimes even you may have like a combination of more than one quantity, like distance over mass, so the unit will be centimeter divided by gram. Then the way data are recorded in the table, they should be all recorded to the same number of significant figures, which should actually goes with the significant figures in the raw data. Like if you have 2.0 times 3.2, so the answer in this case will be 6.4, like 3.2 divided by 7.3 equals 0.4. 7.3 divided by 3.2 equals 2.3. Now the values of at the end should be for the same number of significant figures, which means if you wrote the first value as 2.33, a second value 4.92, the third value, even if it's a whole number like 5, so you should write it like this, so that your values on the table are consistent. Then these values are used to plot the graph. On the graph, you need to consider the following. Number one, you should label each axis. If you are going, for example, to plot a graph between mass and the volume, so here you have mass in grams against the volume in cubic centimeters. Then for each axis you need to choose a suitable scale. Each scale is independent from the other one, which means on the x-axis I can start from 0, on the y-axis I can start from any other value, like even 500. Actually, this will be based on the scale that you choose. Your choice should allow the distribution of points for at least half of the axis, which means at the end when you look to your points plotted on the graph, if you saw the points like this, this means actually you didn't make use of you didn't make use enough of the x-axis. Points are already distributed on the y-axis, but it's not on the x-axis. And of course you can't do it the other way around. And if your points again looks like this, so still this is not a good scale that you used. Normally choose a value that is very close to the beginning of the values that you have. Like if the first value is 32, so you can start your graph from 30. At the end, when you make the plotting, each point should be plotted as a fine dot with the circle around it, or you can just make a cross. But in this case, you need to consider that your graph that you choose, or the way that you plot the points on your graph, should be the same throughout, and the range of the circle that you use around the point should be maximum one small square on each side of the point. Then the graph line that you draw at the end should give or should be the best fit line. A best fit line is drawn throughout the graph section, and it should have all the points either on the line or evenly distributed, like 1 point here, 1 point, 1 point, 1 above the line and 1 below the line, or they are all evenly scattered above and below the line. But your graph shouldn't appear, for example, like this. If you have a graph line like this and all the points, only 2 points on the line and the rest are above the line like this, this wouldn't be a good graph line. Actually, if you tried it like in a different way like this, so right now the red line would be the best fit line. And if your graph is a curve, you need to make sure that the curve is smooth curve, which means you can't draw the graph like this. Actually, you can see clear bending in the line. You need just to make sure that it's smooth throughout the graph. And your graph line should cover the whole section of the graph. These are examples for already drawn graphs. As you see here, the points are scattered all over the line, and the line is perfectly drawn smooth. The labels are there, labeled good scale. You see the x-axis starts from 0, y-axis starts from 30, which is totally independent. On the y-axis, a base scale of 10 is chosen. On the y-axis, a base scale of 20 is chosen. Both scales are totally independent. Points are distributed for, as you see, on the y-axis, they are taken more than half of the graph, and the same on the x-axis, which means this is a perfect graph. This graph here is for a straight line graph, and again, as you see, actually both scales starts from 0, but on the x-axis we have a base scale of 0.2. On the y-axis we have a base scale of 1. Axes are labeled. Points are scattered on the line. This is the first point and this is the last point. So the graph covers more than half of the axis. Normally, when the graph is a straight line, you are asked to calculate the gradient. When you calculate the gradient, you need to choose 2 new points. Don't use the raw data, which are distant on the line and good intersection point. Which means, for example, here we can choose this point right there, and we can choose another point at or close to the end of the line, and again a clear intersection point, so that you do not have to make any approximation. Also, you may be asked to calculate or to find, say, the length at which the time is equal to a certain value. Then you need to get corresponding value from the y and the x. Just to locate, if I need to find the length at which the time is, at which t square equal to 3. So when t square equals 3, this would be the length right there. First type of experiments you may get is the experiments where you have to measure length. When you measure length, you may use the ruler, and the ruler can be read to approximately 0.5 millimeters, but always go for the higher value, which means if you have a doubt between 3.25 and 3.3, so take the reading as 3.3. When you measure the length, you need to consider, number 1, that your ruler is placed alongside the object or the distance being measured, which means if I need to measure like these wooden blocks, so my ruler should be placed alongside the wooden blocks like this. You need to consider to avoid the zero error, and your line of sight must be normal to the scale when you record the reading. This is in a theoretical way or in a practical way, which means if you have to measure the length with your ruler, this is what you should do. And if you have to show by drawing what you need to do, so this is how you draw it. Actually, parallax error is one of the errors that normally happens when you have to record a reading from a scale like a thermometer scale, or like even a movable pointer, a meter or voltmeter. And whenever you make a scale, just write a suitable unit. For distances within the range of 1 centimeter, it's better to give the unit as millimeters. And whenever an experiment is done, if there is a chance to repeat and take the average, this would be better for two reasons. Number one, this indicates if there is any error or a reading that is out of range. Number two, calculating the average also reduces the error. When you measure the length, you need to consider also that you may have to make your rule or your set of devices in a vertical position or in a horizontal position. For such purpose, normally we use a 90 set square together with the ruler like this. This would be the set square. Then you need to place the ruler alongside it like this. Or you can use the ruler together with the protractor, and the ruler must be placed along the center 90 of a protractor. Or you can use a spirit level just to make sure that something is vertical. And the same devices would be used to measure or to ensure, like say another ruler is horizontal like this, by measuring the vertical height from the bench. Right now I can use the set square and the ruler to check the vertical height along the meter ruler being suspended. If the height is the same, so whatever you are placing is perfectly horizontal. You may also use the help of a pointer or a virtual reference or even wooden blocks in some cases to make the right measurement. Like if you need to measure the diameter of a sphere, so in this case you need to place your sphere between two wooden blocks like this. This would be your sphere right here. Then you need to place your ruler above the wooden blocks. Then you read or you record the readings at the edges of the wooden block, and this would be the diameter of the sphere. And as usual, to improve your measurement, you can repeat with changing the position of the wooden blocks around the sphere, or you can even use more than one sphere in your measurement. For measuring distances or a change in a distance for a movable object or an object that changes its length like a spring. Now, you cannot place the ruler close enough to the spring, but in this case you can fix both of them to the stand. Then you can use the help of a light pointer at the end of the spring, or you may use a 90 set square to read the readings from the ruler like this. And each time you need to make sure that you record your length from the same position on the spring. And since we are talking about a spring, it's also important to consider the variables affecting the behavior of a spring, like the number of coils of the spring, original length, or unstretched length, sectional area, thickness of wire, type of material, and room temperature. All these factors affects the behavior of a spring or the extension in a spring. So when you compare a certain property like the effect of changing the original length, you need to make sure that all the rest are kept constant throughout the experiment. Moving to another type of measuring, which is measuring time. Now, to measure the time, normally we use a stopwatch. And to use a stopwatch, first you need to reset the stopwatch or check zero error on a stopwatch. And for a movable object like a simple pendulum or a piston that moves up and down, you need to consider that a complete cycle of the motion. So if you start the stopwatch when the simple pendulum, say, is to the right, so each time it swings left, then comes back to the right, this would be counted as one swing. In this case, you can record the time for 10 swings, then you divide it by 10 to get the average time for one swing. Then again, you can repeat and average. An alternative method is to use the photo gates connected to an electronic switch, which starts when the simple pendulum interrupts the light beam, then it stops when it interrupts it again, then you can find the time directly. A third measurement is about mass, and normally we may use a ruler and a known mass to find the unknown mass that we have, like this ruler here, where you put it on a pivot in the center of the ruler, then you put the known mass on one side and the unknown mass on the other side. Then you need to measure the distances of both objects from the pivot. Then you can apply the equation m1 times d1 equals m2 times d2. But from a practical point of view, now measuring the distance should be measured from the center of the mass, which actually can't be located for the non-uniform object, and for the cylinder it covers the reading below it. So in such cases, if I need to put the cylinder with its mass, say at the 70 centimeter mark, just right here. So in this case, if this is my cylinder above the ruler, actually I cannot see the 70, but I can see the edges of the cylinder. So what we do is that we measure the diameter of the cylinder, then we locate it between two marks, so that the first mark is 70 plus d over 2, and the first mark is 70 minus d over 2, which means if the whole diameter is 4 centimeters, so the reading on the right side of the cylinder will be 72, and on the left side will be 68. Or, if possible, to have a ruler with a hole drilled in the center, like this, then in this case, you can just hang the known mass and the rock to the ruler and measure the distance from the cotton string that you are using. And normally we use cotton string because it's not stretchable and it does not occupy much volume if you need to use it to submerge something like a rock in a cylinder, in a water cylinder. In experiments related to heat, basically in such type of experiment, we are measuring the heat change that happens during mixing hot and cold, or how does the temperature of a material change, or what happens when you dissolve a certain material in a hot liquid and a cold liquid. Anyway, in overall, you need to measure temperature, and the measuring temperature needs a thermometer. When you use the thermometer, you need to make sure that it's not fully submerged in the liquid that you are measuring, or like in contact with the object you are measuring. When you record the reading from the thermometer, if this is the mercury line that you are recording the reading, so again you need to avoid parallax error by making your line of sight perpendicular to the scale. And you should record the reading only when the mercury level settles down, which means that you should wait if you are heating, or if you are cooling, or if you are mixing hot and cold materials. Also, in such an experiment, you need to consider the insulation, because this would be the main source of error in your experiment, and you should choose a suitable way of insulating. For liquids, normally we need to cover the top of the liquid to avoid heat loss by convection and by evaporation. We need also to wrap the container with cotton wool, or if we have expandable polystyrene, again this would be helpful. And you need to consider that when you are heating, normally the rate of the heating gets less by time, because more heat will be lost to the surrounding. Like if you are heating with the same heater and the same material, you can see that the heat increases like 10, 20, 30, then 39, then 47. So at the beginning you would have a change of 10 degrees, then a change of 9, then a change of 8. So the change in temperature per unit time is getting less because more heat is lost to the surrounding. The same happens when you are cooling. First, the temperature will drop like with a large gradient from 100 to 80, then from 80 to 70, then from 70 to 65. So here you have a drop of 20 because it's like very hot liquid. Now you have a drop of only 5 degrees because you are getting close now to the room temperature. In such cases, you need to use a reference to the values if you are given like a table of data that you need to use to compare your results. And in all these experiments, just again in such experiments, you may have this situation where you need to compare a theoretical result to your practical result. Normally the comparison is based on the difference between the theoretical and the practical. Then this difference is either accepted or not accepted within limits of experimental accuracy, which means if the original value that you are supposed to get, say the exact change in temperature expected is say 80 degrees, right now you have a change in temperature which is 77 degrees. Now considering these two values, the difference is only 3 degrees. A 3 degree wouldn't exceed 5% out of what we are talking about here, which means that It's for sure accepted within limits of the experimental accuracy. Actually, you have up to 15% as a limit of experimental accuracy, and only the limit of the experimental accuracy decreases if you are using a very sensitive device for measurements and if you are making the experiment with all precaution done, but still you have this range of error that can happen, and if the difference is accepted, so it's okay. If not, you have to show that this difference is beyond the limits of the experimental accuracy. Moving to another type of experiment, which is the light experiments. In light experiments, we have two types. The first type is what we call the tracing, where you use optic pens to follow the path of the light on a mirror or through and beyond a glass block. In this case, you need to consider the following. Number one, when you draw the optic pens or when you mark the positions of the optic pens, they are at least 5 centimeters apart from one another. When the pens are viewed, they are viewed from the bases because the pens may not be fixed vertical, and in this case an error due to tilting may arise. In this experiment, you have sources of error that can't be actually avoided, but you need to do what you can to make the result good. One of them is the thickness of the position of the pen. And in this case, you need to plot a line which is actually passing through the center of the pen's position. So that you may get a good result. Another thing is the judgment of the intersection points. Like if this is the incident ray and this is the reflecting surface. Now when you need to draw the reflected ray from this position, you can draw it like this. But if we magnify this part here, we can see that actually the lines are over one another right here. Even when you use a fine pencil, you may not get to the exact required result. Another thing you need to consider is using more than 2 pens instead of 3 just to get a better result. You need also to consider repeating the experiment with a different angle of incidence if you are studying reflection or refraction. Also, one of the errors in this experiment is the protractor, because a protractor cannot read to a better than 1 degree, which means that each time you record an angle, you have a possibility of 1 degree error, which actually cannot be, in this case, improved. But still, whenever you make a line as a precaution, just to make sure that the line you draw is better than the radius of your protractor, so that when you put your protractor, you can record the reading at the scale on the end of the protractor. The second type of the experiment using light is the lenses experiment. In this case, you need to make sure that the rule you are using is clamped to the table using G-clamp. Then your object, which is actually a lamp behind the screen, and normally the object itself looks like a small triangular hole or a rectangle with the thread or a mark on one of the sides. and you have your lens, and you have your screen. Three of them you need to make sure that they are placed perpendicular to the bench or the table that you are using, and the center of the lens and the height. The object should be on the same level, or you can say just like the object and the lens are the same height above the bench. Then to measure the distance accurately, you need to measure it from the center of the lens, and the lens is on a wooden base. So in this case, you need to use a fine marker just to mark the center of the lens on the side of the wooden base, so that you can record the reading now from the center of the lens. Recording the readings can be done more than once, which means that again repeat and average, and it would be better to do the experiment in a dark room so that you can get a clear image on the screen. And if you need to measure the height of the image, so use a translucent screen so that you do not interrupt the light, because simply if you put your ruler on the path of the light coming from the object, you may not get the image on the screen. Another thing related to such experiment is the way the image look like on the screen. Basically, if the image is on the screen, it would be inverted, which means if it's triangle, so this is how it look like. If it's this square, so it will be upside down. But of course, comparing the size of the original to what I did here, this means that my image is magnified. And this thing you need to consider. If the image is magnified or is smaller, just multiply the dimensions of the original by the factor that you have. Like if the magnification factor is 2 and this base is 1 and the height is 1, so the new one will have a base of 2 and a height of 2. The last type of experiment that you may have is electrical. In this one, you may either record a reading of an ammeter, or you have to plot a reading on a pointer that you have. Anyway, if this is how the scale looks like, if this one is 0 and this one is 0.2, this means that this division here is only 0.1. If for any reason the pointer is given between the two marks like this, this means your reading is midway between 0.1 and 0.2. So in this case, you can write it as 0.15. If you have to plot a reading, just plot it with a straight line using your ruler, and it will be the same idea. Just extend the line to the suitable position, either on an exact division or in between two divisions. In electricity or in electrical experiments, you have again few sources of errors that you can overcome, like the connections. You need to make sure that you have clean and firm connections to avoid over resistance due to dirt at the connections. You need also to consider to tap the ammeter or to gently knock the ammeter and the voltmeter to ensure pointers are not stuck at the beginning of the experiment, and to avoid heating the resistance. You need to follow one of these instructions, like to switch off between readings, or you can use low power source, or you can add a lamp or another resistance, or of course you can adjust the variable resistor to the maximum value at the beginning of the experiment. And again, if you in general need to use this experiment to measure the resistance, so you need to plot a graph between I and V, because the graph would give you the average of the resistance that you are trying to measure, and it will indicate any error in your measurement. And wish you all the best.